Welcome back. These are the chapter 6.1 notes, an introduction to angles. This is page 4, the very last page. So let us start off by talking about coterminal angles. We can go back to page 1, page 2, where we defined coterminal angles as angles that have the same initial and terminal side. Means they start in the same place, they end in the same place. Only difference may be how many times they go around. Okay, now, here in degrees, we know there's 360 degrees around a circle. So I am going to subtract 360 degrees. When we talk about the smallest possible angle, we want a positive angle. So that's it. And just to make sense of that, if I were to graph my 415 degree angle would go all the way around once and then come back up to what we're going to call a little past 45. Here's my 415 degree angle. Coterminal because it ends up in the same place as my 55 degree angle. Sorry, add an arrow. It is perfectly fine if you see multiples to subtract, but you don't have to. You got a calculator handy, you don't want to think too hard, we can just subtract by 360 every time. Okay. When it's a negative measure, we are going to add instead of subtract. It does not make sense to subtract. We're going to get a larger in magnitude negative number. So here we're going to add. And because I have limited space, I am going to go ahead and add 2 times around at a time. That puts me at negative 780. I can add 720 again. That puts me at negative 60 degrees. Again, I want the smallest angle, positive angle. So we add 360 one more time and we get a smallest possible angle of 300 degrees. Okay. We are using the fact that it's 360 degrees around for one full rotation. And so let me remind us when we were talking about the circumference of that unit circle. Actually, we did degrees with the dark purple. So we're going to do the exact same thing, but instead of adding in degrees, we're going to add in radians or subtract. Okay, now 13 pi over 6 is bigger than 2 pi, right? 12 pi over 6. So I'm going to go ahead and do what we did before. I'm going to subtract 2 pi. This one I'm going to organize a little differently because we are working with the fractions. I want a denominator of 6. So if I multiply, this has an imaginary 1 underneath. If I multiply by 6 to get that denominator, I have to multiply the numerator by 6. I get 13 pi over 6 minus 12 pi over 6, which gives me a pi over 6. We're going to do the same thing we did before when we have a negative angle. I'm going to go ahead and add 2 pi this time. If I want a 10 in the denominator, that puts a 20 pi in the numerator. Remember that when we have a common denominator, denominator stays the same. We just add the numerators. Negative 3 pi plus 20 pi is 17 pi. 10 pi over 3, like I said, it is important to know your fractions. 10 pi over 3 is bigger than 2 pi because when we convert 2 pi to a fraction with 3 in the denominator, we get 6 pi over 3. 10 pi minus 6 pi, again, denominator stays the same, is 4 pi over 3. And let's see if we can make sure that I highlight these answers for you. So I got my pi over 6 here, 17 pi over 10, 4 pi over 3. Let's go ahead and do this with the degree measures as well. And that is the Chapter 6.1 notes done.